right, so let's take a look at these problems. First, this is basically just squaring a binomial. So that's literally what I'm going to do. I'm just going to do the same thing that I've always done when I square a binomial. I'm going to square the first term. I'm going to multiply them together and double it, and then I'm going to square the last term. That's going to give me 1 minus 1 over x plus 1 over 4x squared, which if you make them negative exponents, it looks like this. Now for part B, what we've got to do is find 1 plus 2x to the sixth. Well, we're going to use binomial expansion, 6, 0, 6, 1, 6, 2, 6, 3. Notice how they say make it in ascending powers, so you want to make sure the powers are going up, which they are. So anyway, when we do this, we're going to fill in our exponents, and this is actually pretty straightforward. It's not that tough. I got 12x here. This is going to be 60x squared, and this is going to be 160x to the third. Now, in the third part, what we're going to do is we're going to multiply these things together, but we're only looking for the coefficient of x. So we only want to conduct multiplications that are going to result in an x, not an x squared, not an x to the negative 1, just an x. So I multiply 1 times 12x, and that's going to give me 12x. I'm going to multiply negative x to the negative 1 times 60x squared, because that's going to give me negative 60x. Then I'm going to multiply 1/4 x to the negative 2 times 160x to the third, because that's going to give me 40x. And when I add all those together, I'm going to get negative 8. And my coefficient's going to be negative 8. Now for this next problem, what we're going to do is they've given us this quadratic and a line, and they're telling us to find the set of k values where the line and the curve do not intersect. So what we're going to do is make them equal to each other, and it's going to end up being a quadratic, and then we're going to use discriminant. And remember, what can happen is if they do not touch, then the discriminant is going to be less than 0. The other version of this question is when they say it's tangent, and then they're equal to each other, or equal to 0. But anyway, this one's going to be less than 0. So now all I've got to do is set up my discriminant, and if I just be careful when I'm multiplying, I'm going to get a quadratic, and then when I get that quadratic, I'm going to solve it. Now the thing is, it's a quadratic inequality, and so what's really important to remember is that you're going to solve the quadratic inequality by finding the x-intercepts. But what's going to happen then is your answers are either going to be between those x-intercepts or outside those x-intercepts. So the first step is to find the x-intercepts. Now you'll notice that this graph opens up, and so I just do a quick sketch here, and I have my two x-intercepts are going to be 2/5 and 2. 0 is on the outside, and so I plug a 0 in, and 0 does not make the inequality true. So that means my answers are not on the outside. My answers must be on the inside. So that's where my k's are going to be. Now in this next problem, they are giving me a trigonometric equation, and you'll notice there are 4 terms, and they're telling us to factor it. Now, you may not remember how to factor when you've got 4 terms, but we basically factor by grouping. And what we're going to do is we're going to pick 2 of the terms and factor those, and then take the other 2 and factor those. Notice that the x plus 2 is the same, and the other factor is going to be 3x plus 4. We're going to do something very similar with this one. I think I'm going to start off by, and some people find this helpful, I'm going to call cosine x, and I'm going to call tangent y. Now if I asked you to factor that, you would factor out the 3x, and you would get 3x times 2y minus 1. Well, that's what we're going to do here. Notice how the greatest common factor is 3 cosine, and when I take that and divide it out, I'm going to get 2 tan minus 1. If I look at the next 2 terms, well, then I can see that they has the greatest common factor of 2, and when I divide that out, I'm also going to get 2 tan minus 1. Now I'm going to put these factors together, 3 cosine plus 2, and then 2 tan minus 1, and then equals 0. And like any factoring situation where I get factors that equal to 0, I can now separate those and make each equation equal to 0, and then solve them like I normally would. In this first one, I end up with the inverse cosine of negative 2/3 is equal to the angle, and all I got to do is go to my calculator and figure out that the angle is going to be 131.8. Now, you'll notice that my domain they give me is from 0 to 180, and 131.8 does fit, but the other angles that I could find are either too big or too small, so I'm not going to be giving them any other answers. There's only going to be one answer in this case. So then I go back to the other equation and I add 1 to both sides and then divide by 2, and then I do the inverse, and so I get the inverse tan of 1/2 is equal to my angle, and once again I get my angle is going to be 26.6. And in this case, I can either add 180 or subtract 180, but if I do either of those, it's either too big or too small. And so I have two answers here, 131.8 and 26.6. Now, if you take a look at number 4, this is obviously a series and sequence question. Read the whole thing. We've got the first term is a, and the d is -4. And then the first term of a geometric sequence is 5a, and the r is -1/4. Then they refer to the fact that the sum to infinity is equal to the sum of the first 8 terms. Well, so I'm going to use these two formulas. I'm going to make them equal to each other. And so I've got my a is, for the first sum to infinity, I write it like this. And then my sum of my first 8 terms, I write it like this. And see, now all I've got to do is find out what a is by getting a by itself. I end up with this, and I'm going to multiply both sides by 1.25, and then I'm going to get a is equal to 28. So now in part B, it says find the kth term. Okay, so the kth term is 0. So I know that they're going to equal 0, and I'm going to replace the m with a k. And once again, all I've got to do now is find out what k is. And I'm going to find out that k is equal to 8. Here is a trigonometric graph. It's a cosine graph. And I want to remind you that this number in front is the amplitude. The number inside is the frequency. It's got a number of cycles in 2 pi. And then that c is going to be the midline. So I can find these numbers just by looking at the graph. Clearly the midline is going to be 3. That's c. The amplitude then is going to be 5 because that's a distance from the midline to the highest point and the lowest point. And then there's a cycle in 1 pi, so that means 2 of them are in 2 pi. That gives me this equation over here. And that's part A. Now for part B, where we want to know is that how many times does this function we've just, or the sketched is, intersect with the line y equals 6 over pi x. And I writ here when, but I just want to know how many times does it intersect. And see, this is a line. 6 over pi is a number. It's a slope, if you will. And if you think about it, if I showed you a line y equals 3x, you would know that if I put a 0 in there, that the y would be 0. That's going to work the same thing for this. One of my points is going to be 0, 0 for this line. And if I put a pi in, which you'll notice pi is on my x-axis, well then it's going to be a 6. So the 2 points on this line, if I go and I connect them, well clearly what's going to happen is it's going to enter the line and my trigonometric graph, cosine, are going to intersect 3 times. So that's the answer to the first one. Now the second one, you'll notice that this has got a y-intercept of 6. So I know that one of my points is going to be 0, 6. That's up here. Now again, if I do the same thing and put pi in for x, it's going to be -6 plus 6, or 0. So when x equals pi, y equals 0, so that's this point right here. And when I connect those, the line intersects with the cosine graph only twice. And so that's the answer to that. There are 2 solutions. It intersects 2 times. Now this one, in a situation like this where we're clearly doing areas of a sector, arc lengths, try to create either right triangles or equilateral triangles. Now if you read through here, you'll notice that this is a sector right here because AC is an arc. And so I'm just drawing this. There's my sector. And you'll also notice that BC is a sector. And so I've drawn that. Now what happens is that these radiuses are all 6. So what happens is I've ended up creating a equilateral triangle where all the sides are going to be 6. And what's confusing, and what confused me when somebody asked me about it in class, was it says in the rubric that you've got to figure out that angle B is pi over 3. Well, I mean, this is a 60, 60, 60 triangle, so clearly all those angles are pi over 3. And if I'm going to find the perimeter, well, I need to know the arc AC and the arc BC, and then I'm going to add 6 to it. Well, the angle pi over 3 times the radius 6, well, that's going to be AC, and it's also going to be BC. And so what I end up getting is 4 pi plus 6 for the perimeter. And then for part B, they want us to find the area of the plate. And again, basically what I'm going to do is I'm going to find the area of one of the sectors. That gives me most of the plate. And then what I'm going to do is I'm going to find this area of this other sliver, this BC. See, I've got this whole part, and then I've got this sliver that I've got to figure out. Anyway, the area of the sector is pretty easy because I've got a formula for that. That's going to be 1/2 times the angle times r squared, and I know the angle, it's pi over 3, and I know the r is going to be 6, and so I can figure out that pretty quickly. Now the sliver, that sliver is going to be the same size sector, take away the area of the triangle. So what I'm going to do now is I'm going to figure out that sliver by figuring out, well, I already know the area of the sector. I'm going to take away the area of the triangle. The sector is the same exact size as the one I just figured out. It's going to be 6 pi. So the area of the triangle, there's a couple different ways to do it, but you can draw a straight line and figure out that the height, using the Pythagorean theorem, is going to be not 5, it's going to be, let's see, square root of 27. And if you know that, then you can do 1/2 times the base, which is 6, and then times the square root of 27. And 1/2 times 6 is 3, and square root of 27 is going to be 3 square root of 3. So what ends up happening is I'm going to end up getting 6 pi minus 9 square root of 3 as going to be that sliver. Now keep in mind, I've got to add to that the other 6 pi for the sector, and so I get 12 pi minus 9 square root of 3 for that whole area. Now number 7 is a center point. We're going to find the circle. Remember the circle equation, so what we're going to do is we're going to fill this in. We're going to do x minus 5 squared plus y minus 2 squared. And we're going to have most of my circle equation. We just don't have the radius squared. And what we're going to do is we're going to use this point they gave us, x and y, and substitute it in to find that radius squared. And once I have that, well, I've got my equation. That's part A. Now in part B, they tell me this line intersects with my circle. And so what I'm going to do is I'm going to substitute in what y is equal into my circle equation. And now all I got to do is simplify and square and combine like terms and end up getting a quadratic. And when I get my quadratic, then I'm just going to solve it. And when I solve it, I'm going to get 2 possible answers. Now I've almost got this simplified. All I'm going to do is divide everything by 26, and it's going to make it into a pretty simple quadratic, x squared minus 5x plus 6. And then I can factor this pretty easily. Be careful of the plus 6, though. This is going to be minus 3 minus 2, giving my x's of 3 and 2. And then all I do is plug in those x's into the linear function to find out the y values. And that's where those are the coordinates. Because keep in mind that at the end of the day, they asked me to find the length. And I need 2 points in order to find the length. And I just used my distance formula, which you all remember from Math 1. And I get an answer of square root of 26, which is the distance between those 2 points. All right, so number 8. Here we've got a quadratic, and basically they're telling us to put it in vertex form. And if you remember, to find a vertex x, I take negative b over 2a, and I just substitute it in. I'm going to find out that my x is going to be a 2. You also can use your calculator, menu A, and find the vertex by typing in the coefficients of this quadratic. At any rate, I get my vertex, and then once I've got the vertex, I'm going to plug it into vertex form, because remember, A is my h and B is my k in this case. So I just put my vertex in, and that gives me that part A. Now in B, they tell me this is a one-to-one function and that my domain is everything less than k. Well, if that's the case, that means I must be using just this left-hand side, and so that means the biggest possible thing that k could be would be a 2. Now it says that k is not equal to 2, it says it's equal to -1, so when I substitute a -1 in, I find out that the y value is 13. That is my new maximum. Instead of 14, now it's 13, so that means my range is going to be less than or equal to 13. That's right. And then in part D, they ask us to find the inverse. Now remember, if you're going to find the inverse of a quadratic, always use vertex form, which they already made you do. All right, so we're going to take this quadratic in vertex form, and then all we're going to do is switch to x's and y's and then get y by itself. Now, keep in mind that we're only using part of the domain, and when I get to the point of where I get the y minus 2 squared by itself, I'm going to square root both sides. And it could be plus or minus, but the domain being limited below the vertex means that it's going to be a minus. If it had been limited above the vertex, it would be a plus. But because it's limited below the vertex, it's a minus. And so once I get the y by itself, I end up with this. And these two answers are exactly the same. I wouldn't worry about changing it just to fit the rubric. All right, now part E, it says do this transformation, which remember, that means we're going to go left 3 and we're going to go up 1. So all I got to do to move left 3 is add 3 to my x's. So I'm just going to put 3 right there, and to make it go up 1, I add 1 to the end. And so I get my new quadratic, and that's the answer to that, except for they want it in this form. So I'll actually have to square another binomial and then multiply it by 3 and add 15, but that'll give me my new answer is this right here. Okay, so now 9, they give me a derivative, okay? And they're actually giving you a point, because you notice they give me an x and then the y when that x is equal to 1. That's like giving you a point. And so if they give you a derivative and we're basically got to find the equation of the curve, what we're going to do is we're going to integrate it. And when we integrate, we're going to write the variable, add 1, and then divide or multiply by its reciprocal. So this is my integration, but I've got to add c. And so now what I'm going to do is plug in the point they gave me and figure out what c is. And I'll find out that c is equal to 2. And so then my equation is going to be y equals 2/3 x to the third minus 7x plus 4x to the -1. And then it's going to be plus 2. All right, now for part B, it says to find the stationary point. Well, keep in mind, to find a stationary point, all we got to do is make the derivative equal to 0. And they gave me the derivative. So all I've got to do is make this equal to 0. Now, if it's me, what I'm going to do is get rid of that x squared in the denominator by multiplying everything times x squared. I know it gives me a 4th power, but we know how to solve a quadratic that's got a 4th power. I'm just going to use my h's here like we've done before. And when I factor this, I'm going to have a -8, -7. I'm going to get x is going to, or h is going to equal 4, and h is going to equal -1/2. Well, I replace the h with the x squared. Remember, x squared cannot equal a negative number, so that's not possible. I have two x's, a 2 and a -2. I've got to find the y coordinates, so I substitute those back into the equation, which I just found a minute ago. So you should show that you're substituting it back in, and then you'll get these two y coordinates to go with these points, so you have the whole points. Now for part C, it says to find the second derivative, which basically all we've got to do then is take the derivative of the derivative. So here's our derivative. I'm going to multiply by 2 and then subtract 1 for the exponent. That -7 will not have a derivative, and I end up with plus 8x. So now what I'm going to do is part D, they want me to figure out what are the nature of my stationary points. I'm going to substitute in the x values. One of them is a 2 and one of them is a -2. And I'm going to figure out if they're positive or negative. When I put in a 2, it ends up being positive, and so that means that it is a minimum point. And then when I put in -2, it ends up being negative. That means it's a maximum point. Second derivatives are used to find whether it's a maximum or minimum. And see now number 10, we didn't spend much time talking about this, but you'll notice we're going to integrate this. First step we're going to do is we're going to raise it up by making the power negative. Now, when I integrate, I'm going to raise the power and then divide or by the reciprocal. And don't forget, I also have to divide by the derivative of the inside. Anyway, I get this. Now, normally we would have a number. What you want to do in this case is put in a gigantic number for this infinity. Just put in a gigantic number. It's going to probably be approaching 0, almost certainly, but plug in a gigantic number. And when you do, you're probably going to find, well, when you do this one, you're going to find that it's going to be some negative number times 10 to the -4. It's a really small number, okay? It's really close to 0. It's approaching 0. Now, then we'll do the same thing for the 1, and then we'll subtract them like you would normally. And so when I put in the 1 and -2 and then -1/2, I'm going to end up with a -2/3. So I am going to do 0 minus -2/3, and I'm going to get 2/3 as the answer. Now, finding the volume. Remember, when we find the volume, what we've got to do is take y and square it, and then multiply it times pi after we do the integration. So what we're going to do is 3x to the -2 to the -3/2. When I square that, well, basically raising a power, all I got to do is multiply the exponents. So this ends up being 3x minus 2 to the -3rd power. So now that's y squared. This is what I'm actually going to integrate. So I write it, I raise the power, and then multiply by its reciprocal, and then multiply by the derivative of the inside, again, the reciprocal. And now I'm going to put in my numbers 2 and 1, and don't forget the pi. So all I got to do is find the two numbers, one with a 2 after I insert it, and then a 1. I get -1/96, and then when I put in the other 1, I'm going to get -1/2. And so then when I subtract them, I get 5/32, and then when I put a pi on there, that's the answer. And that is it for part B. Okay, so now in part C, they want us to find the normal of this curve. Now we've got the equation of the curve, and so in order to find the normal, we need to find the tangent slope. And then in order to do that, we need to find the derivative of my curve. So I'm going to find the derivative of the original curve. Then what I'm going to do is I'm going to substitute in this x of x equals 1. That's going to give me the slope at the tangent slope. And when I get that, I'm going to have -4/2 or -9/2. And when I do the reciprocal opposite, it's going to be 2/9. So that's going to be my slope of my normal. And then I substitute it into y equals mxb, and I get the y-intercept is going to be 7/9, which if you take a look, that's what they asked. They asked for the y, basically y-intercept, where it's across the y-axis. But anyway, we get the point 7/9, and that's going to be the answer for that. Okay, so hopefully it was helpful. Thanks for watching. Let me know if you got any questions.